Right, hi year 11s, this is Mr. Lim again, and now we're going to be doing a video about nuclear structure and representation of elements and how you write them out. Okay, so this is what we're going to be learning about today. Right, so let's go talk about the nuclear structure. Atoms are composed of two parts, we should know that. The nucleus and the electron cloud. Today we're just going to be looking at the nucleus, we're going to be looking at the electron cloud later on. Okay, so let's move on. The nucleus, what is it? It's the dense central part of the atom. We knew that from the last video. Almost all of the mass is found in the atom, is found in the nucleus, but it's very little volume, so it is very dense. Okay, so it's composed of protons and neutrons. We should know that from year 9. The protons and neutrons have approximately the same mass, but the neutrons are slightly heavier. Okay, you can have varying numbers of protons and neutrons within the nucleus, and the properties of the atom are based on the number of protons in the nucleus, not the number of neutrons. Groups of atoms with the same number of protons are known as elements. Right. So all of the stuff that we should know from a long time ago. Now let's go on to isotopes. Okay, so if some of that group of atoms of an element, okay, so they all have the same number of protons, have different numbers of neutrons, they're known as isotopes. Isotopes are atoms that have the same number of protons, but different numbers of neutrons. Okay, they have the same chemical properties, but different physical properties, because the chemical properties are determined by the number of protons and electrons, but the physical properties are determined by things like the mass. Okay, so let's have a think here. Here are 9 particular atoms, and we have to work out whether they're isotopes of each other or if they're different elements. Okay, so what we've got the number of protons and neutrons listed out. So if you want to find for the ones that have the same element, you look for all of the ones that have the same number of protons. So this would be the same, this, and this. Right, so you have 4 atoms there which are of the same element. Right. However, you have 2 isotopes because you have different numbers of neutrons over those 4 of them. Right. So these 2 are the same and these 2 are the same. Okay, so there are 2 isotopes of this particular element. For the others, you've got this one here, and this one here. All right. Again, you've got 2 isotopes. That's one isotope there. And then that one here by itself is another isotope. And then you've got another 2 here, 2 different isotopes. Okay. If you think about their physical properties, which one of these is going to be the heaviest? Well, you should look for the one with the most protons and most neutrons, which would be this one here. Okay, it has 14 protons and neutrons together, right? Which makes it the heaviest one out of them all. All right. Remember, also, do I have atomic mass here? Maybe not. Oh, no, we do. Good. Excellent. All right. So different isotopes and different elements. Okay. So representation of nuclei. So there's different ways to represent all of those nuclei that we just looked at. Okay. First of all is the conventional representation. So the conventional representation is shown with the element symbol. Conventional representation is the element symbol is shown with the atomic number and mass number. What's the atomic number and mass number? And these things are shown on the left. It's the number of protons is the atomic number, and it's shown on the bottom left. Number of protons and neutrons on the top left. Okay, so here's a couple of examples. Right, here are the atomic numbers on the bottom left, and here are the mass numbers on the top left. Okay, so if you were to work out the number of protons, let's use this one. Okay, number of protons in each, you'd be able to say that, okay, the carbon has 6, the nitrogen has 7, the lithium has 3. And if you don't know these symbols, you use your data sheet that you've got to have a look up these elements on the periodic table. All right. The number of protons is shown in blue. The number of protons and neutrons is shown in green. So if you want the number of neutrons, right? Therefore, what you have to do is you have to take the green number, which is the mass number, subtract the atomic number. So, for example, the carbon one, you take 12 take 6, which is equal to 6. This one here, 14 take 7, which is equal to 7. This one here, 7 take 3, which equals to 4. This one here, you do 35 take 17, which is equal to 18. Okay, and that's how many neutrons there are in those elements there. Okay, and then finally we have the last one, which is representation of nuclei as in the word form. So you have the name or symbol of the element, and then shown with the mass number following it. Okay, so the atomic number is determined by reading the periodic table. Okay, so you look at the symbol here and you say, okay, well, where's the C? C is on the periodic table. And then you look at the periodic table, you should see that above that letter is the atomic number. And the atomic number for carbon would be 6. And so therefore you'd be able to work out how many neutrons and protons there are. Okay, you can show isotopes of these things here. Okay, so 2 isotopes of hydrogen, one with well, this one here will have 1 proton, 1 neutron. This will have 1 proton and 2 neutrons. But generally, hydrogen actually is generally more whoops, don't do that. Yeah. Generally, hydrogen is actually H1, which is just 1 proton and 0 neutrons. All right, so that's the different ways to represent the nuclei. You've got the word, so you might have like, carbon 12, the word or the symbol, or you can have the conventional representation, and that's about the structure of the nuclei. That's it. Adios.